So once you have the polynomial set equal to 0, you need to identify A and C. This is for the robust way to solve this, called the AC method. A is the coefficient in front of the squared term. C is the number by itself. You multiply those together, A times C. In this case, 9 times 25. And I believe that's 225. Quick check here on the calculator. 9 times 25, 225. Now we need to find all of the factors that can multiply together to equal 225. And that can take a while, but you can stop after the square root. So let's see what the square root of 225 is. 15, which means 15 times 15 is 225. So that's actually a pair of factors. Let me go ahead and write that down. We're looking for all numbers that multiply together to equal 225. We already got one, 15 times 15. All right, so typically you start the list at 1 times the number 1 times 225. And then you check 2, and then 3, and so on. And I know I can stop once I have checked 15, because 15 is the square root of the number. You don't have to check past that. So 2 doesn't divide this since it is an odd number. I'm going to just kind of pull up my calculator here and see what divides it. 3 times 75. So 3 times 75. Now I got 225 divided by 4. Now all of these odd numbers aren't going to work. Or sorry, all these even numbers aren't going to work for division because 225 is odd. So I can kind of skip over all the evens going forward. 5 times 4, 45. I'm going to skip 6 because it's even. 225 divided by 7. That's not a whole number. I'm skipping 8, 9. 9 times 25. Oh yeah, I should have known that since A times C was 9 times 25. 10 is even. That doesn't work. Divide by 11. 12 we can skip. Divide by 13. 14 we can skip. And we already have 15 on the list. And so I have a list now of all the factors of 225. Now that's kind of a larger number. Sometimes you can make this list a lot quicker. But remember, you can always stop at the square root. You don't have to just keep checking numbers past the square root, in this case, past 15. I'm looking for a pair of, or I'm looking for a row here, a pair of factors, so one of these rows, that is going to add up to B. In this case, B is 30. Our middle coefficient is B, it's 30. And so the only possibility here is 15 plus 15. That adds up to 30. What you do is you split the middle term. I'm just going to rewrite this. Rewrite it, but split the middle term. Instead of adding 30 all at once, I'm going to add 15. 15b instead of 30b. Then I'm going to add 15 more. And the reason I'm doing 15 and 15 is because it's this row. You know, if it's a different row, it would have been like 5 plus 5b plus 45b if I was trying to add up to 50. But I'm trying to add up 30, so I have to use this bottom row. That's why I'm getting 15 and 15. So make your split directly from your list of factors, and then you just write out the rest of your quadratic formula here, quadratic equation. This is the same exact equation. I've just split the middle term. It's still plus 30v, but I'm doing it in 2 parts. You have 4 terms now. Make 2 groups. You're going to factor each of these groups with the greatest common factor method. What's the largest number that divides? So just looking at just the first group, what's the largest number that divides 9 and 15? It's 3. And I can divide both terms. I can divide both terms by a v because they both have a v showing up. And that would leave me with 3v plus 5. And kind of check your work here by distributing. I always like to check that 3v times 3v, yep, that would be 9v squared, and 3v times 5, yep, that would be 15v. So I've correctly factored that first group. Move on to the second group and do the same thing. What's the greatest number that would divide 15 and 25? It's 5. And I cannot divide out by a v because this last term is just the number 25. There's no v there. So I'm going to be left with 3v plus 5. I'm running out of a little bit of room here, but that's equal to 0 still. All right. Now here is kind of the last step. You see this common factor here, 3v plus 5, is being multiplied by two things. It's being multiplied by 3v, and 3v plus 5 is also being multiplied by a 5. We can factor out the 3v plus 5. This is always our last step. We're saying 3v plus 5, it was multiplied by a 3v. So I'm multiplying that, multiply by a 3v, and also multiply by a plus 5. And now I got room again. I can rewrite my equals to 0. But once again, see what we're doing. We just are using the kind of the anti-distribution method here. If you distributed this multiplication through, you would have 3v plus 5 times 3v, which that's exactly what I have here. And then multiply it by the next term, 3v plus 5 times 5, and that's exactly what I have there. All right, so you factored out that 3v plus 5 by both terms. And in this case, both our terms are exactly the same. That's not always the case. But to solve for v, you just take each factor here now one at a time. If two things are multiplied together and they equal 0, one of them has to be equal to 0. That's the zero product property. So 3v plus 5 has to equal 0. And I only need to solve this once since both terms are identical, but often you'll have to solve two different equations like this. One term at a time, one factor at a time, set it equal to 0 and solve. So 3v equals -5 when you subtract 5, and then divide both sides by 3 to get that final answer of what v would be. And that's the solution. If we plug that number, -5 divided by 3, into this equation, you're going to square it here, you're going to multiply it by 30 there, and so on, it will equal 0. That's the one number we can plug in. That is what we have solved for. I'm going to end the video with a little graphing demonstration. Desmos graphing calculator. If you don't have a graphing calculator, I highly recommend this online one. It's great. So I'm just going to type in 9v squared, typing in our equation, plus 30v plus 25. I want to graph that. Oh, I typed the wrong thing. 9v squared plus 30v plus 25. I think it needs x's. 9x squared plus 30x plus 25. All right, so you need to use x and y for this calculator to work. But here is the graph. It's a parabola. That's what these quadratics look like. And what we have solved for is where it is equal to 0. Where is the y value equal to 0? And you can see we have just one solution here because the vertex, the very bottom point of the parabola, is the only point that is touching the x-axis, so the y value is equal to 0. It's in decimal form, -1.667. That's -5/3, the same solution we got, but that's visually what we are finding out. Where does that parabola cross the x-axis? In this case, there's just one solution because the vertex is on the x-axis. Often there's two solutions, but when you have the vertex on the x-axis, there's just one solution, that one point where the parabola, the graph of that crosses the x-axis.